Welcome back. So we're going to be looking at questions and problem solving related to motion, okay, and everything we've covered under the topic. So basically, I would advise you look through the questions. If you can, pause your video, get to solve them on your own, and then come back to continue to see if your calculations were correct. Okay, so the link to the PDF containing these questions will be dropped in the description, so you can access the questions probably on your phone, or you can have them printed out and you try to solve them, and then you can come back to check if the things you did were correct. Okay, so let's solve the first question. A car travels for 3 hours to a distant city 200 kilometers due east. What was its speed and velocity? So we can see this question that we're given the distance the guy traveled, which is 200 kilometers, and we're asked to find the speed and the velocity. Okay, we know that the difference between speed and velocity is that velocity is a vector quantity, which means it requires direction to define it. So velocity is displacement over time, because displacement involves direction. Speed is distance over time. Distance doesn't require direction, you just calculate the length covered, okay, through the journey, while velocity is the shortest distance covered, it's just in one direction. Okay, so in this case we have a distance of 200 kilometers, but that distance is due east, which means is in a particular direction. Okay, in that case, it's the distance is same as our displacement. Okay, because it was just a movement done in a particular direction. All right, so the slide says since car travels only in one direction, that's eastward, distance and displacement will be same, which means speed and velocity is also same. All right, so velocity is displacement over time. All right, so we have our displacement to be 200 kilometers. Okay, we are multiplying it by 1,000 because we are about to change it to meters. Okay, so 200 kilometers times 1,000 will give us our answer in meters. Now we have 3 hours times 3,600 to change these hours to seconds.
60 seconds make a minute and 60 minutes make an hour.
60 times 60 is 3,600. That will mean 3,600 seconds makes an hour, and we have 3 hours here. Okay, so our answer, if we simplify this, is going to be 18.5 meters per second. Alright, let's look at number 2. Please remember to note that this 18.5 meters is both the speed and the velocity, because displacement and distance in this case is same. Okay, number 2. While driving a car at 90 km per hour, how far do you move while your eyes are shut for 0.5 seconds during a hard sneeze? Okay, so understanding the question is vital. Okay, you're driving and you sneeze. Okay, while you sneeze, your eyes is shut for 0.5 seconds. The question now is, how far would you have gone in that 0.5 seconds if your speed is 90 km per hour? Okay, so first of all, what we need to do is to figure out our variables, bring them out. We have the first variable we're given here is the speed of the car. So we have speed at 90 km per hour, okay, and we have time. We're considering time at 0.5 seconds. Alright, so if we have speed and we have time and they're asking us for displacement, obviously it's not a difficult question, because we know that speed is equal to distance over time, right? Okay, so we have displacement equal to velocity times time. Remember, this is coming from velocity is equal to displacement over time. If you make displacement subject of formula, this is what you have. Alright, so if we move on, we would have 90 km per hour times 1,000 divided by 3,600. This is to give us our answer in meters per second. So that's why we're multiplying 90 by 1,000 and dividing it by 3,600. Okay, so we can change kilometers to meters and change hour to seconds. We did it previously here for number 1. Okay, so then we multiply by our time, which is 0.5 seconds. If we do that, we're going to get our displacement as 12.5 meters. Okay, so you can see that's quite simple. Our question for number 3 says, a bus travels with an average velocity of 60 km per hour. How long does it take to cover a distance of 500 kilometers? Okay, in this case, we are given velocity 60 km per hour. We are given distance 500 kilometers. We are asked to find time. Okay, so we know we have the formula which was given to us during the course. Velocity is equal to displacement over time. If we make time the subject of formula, then we would have time equal to displacement over velocity. Okay, so displacement is given to us as 500 kilometers, while the velocity was given to us as 60 kilometers per hour. So if we bring that into the equation, we're going to have our answer as 8.3 hours. Okay, if we divide 500 by 60, okay, we have 8.3 hours. Alright, if we convert 8.3 hours to seconds, which is multiplying it by 3,600, we're going to have 30,000 seconds. It's proper and better to make sure all your answers are in meters or seconds. So let's start the 4th question. You are to drive 300 kilometers to an interview. The interview is at 11:15 a.m. You plan to drive at 100 km per hour, so you leave at 8 a.m. to allow some extra time. You drive at that speed for the first 100 km, but then construction work forces you to slow down to 40 km per hour. For 40 kilometers, what would be the least speed needed for the rest of the trip to arrive in time for the interview? Okay, for questions like this, it's very important that you are able to translate or to give meaning to these words. Okay, these are word problems, so it's very important that you get to understand the question that is being asked. Okay, so to explain this, you're driving at 300 kilometers for an interview. Okay, the interview is by 11:15, but you leave at 8 a.m. Right, so you're supposed to get to the place by 11:15, but you leave at 8 a.m. The time interval for this journey is, of course, is between 8 a.m. and 11:15. So if that should be 3 hours 15 minutes, right? Okay, so if you convert this to hours, just hours, it's 3.25 hours, right? And how to convert this to hours is by, of course, we have 3 hours. If you want to convert minutes to hours, then you're dividing by 60. So if you divide 15 by 60, we're going to be having 0.25 hours. So 3 hours plus 0.25 hours gives us 3.25 hours. So that's how that conversion was made. Okay, so the time interval is 3.25 hours. So you are looking to drive for 300 kilometers, right? But you're also looking to make sure you are there in 3.25 hours. Okay, now you plan to drive at 100 kilometers per hour. That was your plan. You drive at that speed for the first 100 kilometers. Okay, now construction work forces you to slow down to 40 kilometers per hour for 40 kilometers. So your first 100 kilometers, you did it at a speed of 100 kilometers per hour. Your next 40 kilometers, you did it at a speed of 40 kilometers per hour. Now, they're now asking what would be the least speed needed for the rest of the trip. Okay, so we need to know how much time was consumed for the first 100 kilometers, how much time was consumed for the next 40 kilometers, so we know how much time is left. Alright, then we now know what speed that you can use to finish up our mission in that time that we have left. The slide says to know what speed we need to first know how much time we have left. Okay, that's what I just said. Alright, so we move on. Okay, so to get the time we spent in the first 100 kilometers, we can represent that time as T1. So T1 is distance over speed. Alright, so our distance for T1 is 100 kilometers. Okay, and the speed that we used for the distance of 100 kilometers is 100 kilometers per hour. So which means if we divide this, we'll find out that what was consumed, the time that was consumed for this first segment of our journey was 1 hour. So we go to find the second time interval. So the distance of 40 kilometers, we sped for 40 kilometers per hour throughout that distance. So if we solve that, we see that we spent another 1 hour on that speed. Okay, so the question they now ask is, what would be the least speed needed for the rest of the trip for us to arrive in time? So if we spent 2 hours in total, how much time do we have left? So we can do 3.25 hours minus 2 hours. Remember, 3.25 hours is the total hours we have in our hands. How much speed are we going to use in this 1.25 hours so that we can be on time? Okay, so another thing we need to find out is how much kilometers do we have left, right? What's the distance we have left? So you see we have spent 100 kilometers for the first time interval, spent 40 kilometers for the second time interval. So that is 140 kilometers spent. Alright, now the total distance that we're supposed to drive is 300 kilometers, but we've spent 140 kilometers. This leaves us with 160 kilometers. Alright, so the speed that is required for us to finish this journey on time is going to be gotten by distance over time, which is 160 kilometers that is left divided by 1.25 hours that we have. Okay, which will then give us 128 kilometers per hour. Alright, so now we have 128 kilometers per hour as our answer. We can convert it to meters per second by multiplying it by 1000 and dividing it by 3600 seconds. So this would give us 35.6 meters per second. Okay, so let's move on to number 5. Okay, a cyclist on a 10-speed bicycle accelerates from rest to 2.2 meters per second in 5 seconds in third gear, then changes into fifth gear. After 10 seconds in fifth gear, the cyclist reaches 5.2 meters per second. Assuming that the direction of travel remains the same, calculate the magnitude of the average acceleration in the third and fifth gears. Okay, so we know that acceleration is change in velocity over change in time. Okay, alright, so if that's the case, we know that for every of the gears, the change in velocity will be v2 minus v1, and then t2 minus t1 for the change in time. Okay, so for the third gear, which is the first gear that was used, he accelerated from rest to 2.2 meters per second. So our change in velocity is 2.2 meters per second minus 0. Okay, so v1 in this case is 0 meters per second and t1 is 0 second, because v1 is the initial velocity, which is 0 because it was from rest. He accelerated from rest. He wasn't moving at the initial stage. So v1 is 0 meters per second, and that time t1 is 0. So we have v2 and t2 to be 5 seconds. Okay, so when we bring this into the equation, we have a change in velocity to be 2.2 meters per second minus 0 divided by change in time, which is 5 seconds minus 0. So if we solve that, we're going to have 0.44 meters per second square as our acceleration. Okay, then for the fifth gear, we know of course that in this case our v1 is 2.2 meters per second, because remember it said from the question that it was after it had moved on this third gear that it then changed to the fifth gear. Alright, and it now ran on the fifth gear for 10 seconds and reached 5.2 meters per second. So the speed it was at before moving to the fifth gear is the speed it started the fifth gear on. So the initial velocity for the fifth gear is 2.2 meters per second, and the initial time is the time which it has already consumed on the third gear. So, and the time is obviously 5 seconds. It was just finishing 5 seconds on the third gear before coming into the fifth gear. So that's 5 seconds is the starting time for the fifth gear. So T1 is 5. Okay, then V2 is 5.2 meters per second, because that's the velocity it reaches at the end of its journey on the fifth gear. And the time T2 is 10 seconds plus 5 seconds. 10 seconds, which is the time it spent on the fifth gear, but then 5 seconds, which is T1, which is the time it spent on the third gear. Okay, so you need to understand that our T2 is 10 seconds plus 5 seconds, because it started at 5 seconds and spent 10 seconds in the process. So obviously T1 is 5, so T2 should be 15. Alright, okay, so the acceleration on the fifth gear now becomes 5.2 meters per second minus 2.2 meters per second divided by 15 minus 5. So of course, if we solve for that, that will give us 0.3 meters per second squared. So we can see that our average acceleration on the third gear is 0.44 meters per second squared, and that for the fifth gear is 0.3 meters per second squared. Okay, so let's move on to the sixth. Number 6. A mango fruit drops to the ground from the top of its tree, which is 5 meters high. How long does it take to reach the ground? Okay, so there are two ways we can solve this problem. Let's take the first one. This one is more complicated than the next one I will show you, but then let's try to go through it. Okay, so if we look here, we have height of the mango fruit. That's the height the mango fruit falls through. We know acceleration due to gravity affects the fruit while it's on the free fall. So we have our acceleration, which is acceleration due to gravity. Alright, now we are looking for time. One of the things we can do here is to find our velocity, and from the velocity we find the time spent. Okay, so let's try that first, then I'll show us another way we can do it. Okay, so if we use the formula, of course, remember when you're meeting questions on motion, you should be able to know your formulas in your head, so all your formulas can flash before your eyes and you pick which one can be easy for you to solve, with the variables you have. Okay, so in this kind of question, the thing that comes to your mind, of course, is a question involving free fall. So you have the equations of motion for free fall, where you have v equal to u plus gt, you have h equal to ut plus half gt squared, and you have v squared equal to u squared plus 2 gh. Okay, they have to flash before your eyes and you pick which one of them would give you the answer you need with the variables you have. But let's try with the last formula, which is v squared equal to u squared plus or minus 2gh. Okay, so if you decide to go through this route, you first find your velocity. Okay, given the variables we have, this is a scenario where the mango is falling in the direction of gravity, so it's going to be positive. So if we put in our variables, we have 0, that's u squared. U squared is 0 because it's the initial velocity. The mango fruit is initially at rest before it falls, so initial velocity is 0. Then we have 2 times gravity. We're taking 10 as our gravity in this case, and then we are multiplying it by 5, which is the height. Okay, so if we simplify that, we're going to be getting 100. So we find the square root of 100 because, of course, v was squared. So if we find the square root of both sides, we would be able to remove the square on v and have just v. So we now find the square root of 100, and we're going to get that as 10 meters per second. Alright, so our velocity is 10 meters per second. We can now go on to now find the time. So we now go to find our time using the first equation, which is v equal to u plus or minus gt. Okay, if we're doing that, okay, so bringing our variables into the equation, we have our v to be 10 meters per second, okay, equal to initial velocity is 0, so 0 plus gravity 10 times t. Okay, if we make t the subject of formula, we're going to be having 10 divided by 10. Alright, if we make t the subject of formula, of course 0 is out of it. We move this 10 to this side. We can divide both sides by 10. If we do that, we're going to have 10 over 10 and 10t over 10. So this 10 here will cancel the 10 beneath, while we're left with this. So we have 10 over 10 equal to t, which equals to 1 second. Okay, so another way to do this, which is a more straightforward way, is to use the formula h equals ut, okay, plus or minus half gt squared. Okay, all right, now this is another way, and this is the easiest you can get. Okay, so all we need to do is just put in our variables. If we do that, we have u here to be 0, initial velocity is 0, so if we multiply t, we get 0. All right, then we have g here to be 10, we have t here to be what we're looking for, and our height to be 5. So basically what we're going to have will be 5 equal to 0. Okay, we're using plus because it's a fall that goes in the direction of gravity. So this is going to be 10 divided by 2t. Okay, so basically what we have, of course, is 5 times 2 divided by 10 to be t, or you can say this is 5. 10 divided by 2 is 5. So if we make t the subject formula, what we'll have is 5 divided by 5, right? Which equals 1. Okay, so basically that's how we can solve it in a more straightforward way than using two different formulas. Alright, so the 7th question: calculate the height from which a body is released from rest if its velocity just before hitting the ground is 30 meters per second. Okay, so we know we have the velocity in this case. Okay, we have our acceleration, okay, which is acceleration due to gravity, and what we're looking for here is the height. Okay, the height. So it's going to be very okay for us to use this formula, v squared equal to u squared plus 2gh, to find our height, because of course we have our acceleration due to gravity, we have our velocity, okay, and we know that initial velocity is 0 because it was released from rest. So we have 30 meters per second squared equal to 0 plus 2 times 10 times height. Okay, so if we make h the subject of formula, we would have 30 divided by 2 times 10, 30 squared rather, divided by 2 times 10, okay, which would give us 45 if we simplify this. So our height is 45 meters. Alright, okay, let's look at the 8th question. Alright, when startled, a monkey will leap upwards. Suppose it rises 0.544 meters in the first 0.2 seconds. A. What is its initial speed as it leaves the ground? B. What is its speed at the height of 0.544 meters? And C. How much higher does it go? Okay, so we have in this case the distance which the monkey leaps when it's startled, and that distance is 0.544 meters. Okay, in the first 0.2 seconds. Now they're asking, what is its initial speed? That's the first question. So we have distance, and we have the time for which it goes through that distance, and they're asking for speed. So if we look through the formulas we have, okay, it will be okay for us to use the formula h equal to ut plus or minus half gt squared. Now h would have h equal to ut minus half gt squared, because in this case the monkey leaps against the force of gravity, so it's negative. The acceleration due to gravity here is negative. So alright, we We then put in our variables. We have s equal to u times time, which is 0.2. okay, all right. Remember, our u is initial velocity and that is 0, so this is going to leave. Okay, then we have minus half acceleration due to gravity times 0.2 squared. Now if we try to make initial velocity the subject of the formula here, what we're going to have is s plus, all this moves to this side, 0.2 squared times g divided by 2. Alright, then divided by this 0.2. okay, so which will give us u. I'm sure you can do this. Okay, this is this, everything after the negative goes to the other side and becomes positive. Okay, once it crosses the 0, it becomes positive. Alright, it's same as saying add half times gravity times 0.2 squared to both sides. It's same as adding it. If you add to this side, you have this. If you add to this side, of course, it's going to subtract this off. Okay, so we're now left with u times 0.2. So you now divide both sides by 0.2. You're going to have this, and you have only u on this side. So if we simplify this, we put our value for s, which is the distance, 0.544 meters, and then we put our value for gravity, which is 10 meters per second squared. If we simplify that after putting those values, we're going to have 3.7 meters per second. Okay, that's our initial velocity. So B says, what is the speed at the height of 0.544 meters? So if we are to find the speed at the height of 0.544 meters, we know we already have our initial velocity, which is 3.7 meters per second, and then we have the acceleration due to gravity. Okay, all right, and we have the height, which is 0.544 meters. Okay, so what we're looking for is the final velocity, the velocity at that height, 0.544 meters. So if that is the case, then we can simply use this formula for to find B. Okay, so we can use v squared equals u squared plus, okay, or minus 2gh. Okay, so all we need to do here is to of course put in values for our initial velocity. So v squared will be equal to 3.7, which we just found. Okay, 3.7 meters per second. All right, and remember, this is going against gravity, so we have minus 2. I have minus 2 times 10 for gravity and times 0.5. Okay, 0.5 for 0.544. Okay, the brackets here. Okay, so if we simplify this, this is a 2, don't forget this is a 2. If we simplify this, we're going to be having v squared, okay, equals 3.7, right, minus 10.88, okay, okay, so oh please, we forgot to square our 3.7. 3.7 is squared. 3.7 is squared. So what do we have here? This is going to give us, find the square root of this side and the square root of this other side. But 3.7 squared minus 10.88 would give us 2.81. Okay, so if we find the square root of that, we're going to be having 1.7. So our V is going to be 1.7 meters per second. An electric vehicle starts from rest and accelerates to a rate of 2 meters per second square in a straight line until it reaches a speed of 20 meters per second. The vehicle then slows at a constant rate of 1 meters per second until it stops. How much time elapses from start to stop? And how far does the vehicle travel from start to stop? So we can see from this question that we are given acceleration and we are given velocity and we are asked to find time. So what we need to do is, it's stated that the vehicle accelerates and then decelerates. Let's find how long it took to accelerate and then how long it took to decelerate. So we sum both the time intervals together and then we're going to have the total time from start to stop. Okay, so first of all, for acceleration, we have of course, acceleration is velocity, change in velocity over change in time. So if we're looking for the change in time, we're going to have velocity over acceleration. Let's remember the initial velocity is 0 because the statement stated that the electric vehicle starts from rest. So initial velocity is 0. And then it accelerates at a rate of 2 meters per second squared in a straight line until it reaches a speed of 20 meters per second. Okay, so our velocity here is 20 meters per second minus 0. Our change in velocity rather, 20 meters per second minus 0. Alright, then the acceleration is giving us 2 meters per second squared. So if we solve for this, we'll find out that our time is 10 seconds. Okay, alright, so the second one for the deceleration, we have same thing, change in time equals the change in velocity over acceleration, and then if we check, our initial velocity is 20 meters per second. Okay, because that's the velocity it started decelerating with. Okay, at the time it started decelerating, that was the velocity it was on. So the velocity with which it ended acceleration, the same velocity with which it started decelerating. So our initial velocity as at the time it started decelerating is 20 meters per second, and the final velocity for deceleration is 0 meters per second. So our change in velocity is 0 meters per second minus 20 meters per second, right, divided by minus 1 meters per second squared, which is the acceleration. Okay, remember it is decelerating, so acceleration is minus 1 meters per second squared in this case. So if we solve that, we're going to get our answer to be 20 seconds. Okay, so the total time from start to stop is 10 plus 20, which is 30 seconds. So the second question is, how far does the vehicle travel from start to stop? Okay, if we need to know how far, then we need to find out the distance for acceleration and then the distance for retardation. Sum both together, we know how far. Alright, so first of all, for acceleration, to find the distance, of course we run our minds through the formulas we have for equations of motion, and we settle for s equal to ut plus half at squared. Alright, for acceleration, our initial velocity is 0 and the acceleration we have is 2 meters per second. Okay, so if we bring all that to the equation, we have s equal to 0, alright, plus half 2 times 10 squared. 10 squared is the time we spent accelerating. Okay, that's the time we got for acceleration here. Okay, so we have 0 times t, obviously will give us 0, so we have plus half 2 times 10 squared. Alright, so if we simplify that further, we have 200, which is 2 times 10 squared, 200 divided by 2, which would give us 100. So the distance it spent accelerating is 100 meters. Okay, so for deceleration, we use same, s equal to ut plus half at squared. Okay, so of course we know our initial velocity here is 20 meters per second. Our time interval for retardation is 20 seconds. Then we have acceleration here as minus 1 meters per second, and we have our time as 20 seconds. So if we bring that into equation, we have s equal to 20 times 20, okay, minus half times 1 times 20 squared. Okay, so if we simplify that, we're going to be having, of course, this 20 times 20 is 400, 20 squared is 400, divided by 2 is 200. So we're going to have 400 minus 200, which gives us 200. Okay, so the total distance is 100 plus 200, which gives us 300 meters. Okay, I hope everything we've done you can relate with and you could follow with ease. Okay, so I hope you can still get more questions to try on your own and get confident with solving these questions. So we're going to have a video in a few days showing us solving problems from past questions in JAMB, WAEC, past questions that relate to this subject we have just treated. So stay tuned.